There's an old saying in warfare: know your enemy, understand how they think, how they fight, and what they use to do it. And Ukraine took that advice to heart. It took one of Russia's weapons, rebuilt it from scratch, made it better, and started using it to blow up Russian soldiers. This is the story of Molniya and its Ukrainian twin, the Blyskavka. The Molniya, which means thunderbolt in Russian, is a fixed-wing kamikaze drone that Russia first began deploying in significant numbers in spring 2024. It wasn't an impressive-looking machine, nor a sophisticated piece of military engineering. It was built from what's essentially scrap and assembled at small facilities that look more like furniture shops than defense factories. The Russians didn't reinvent the wheel here. They packed it with electronics that just needed to do the bare minimum for navigation and flight controls. It was the cheapest possible way to put explosives in the air and fly them toward Ukrainians. And the drone worked, perhaps even too well. Before the Molniya, the general framework of drone warfare in Ukraine was relatively well defined. You had small FPV quadcopters, which were racing drone frames stuffed with explosives, costing $475 to $600 each, and deadly over short ranges. Then you had heavier bomber drones like the Nemesis and Vampire, flying 15 miles out and carrying serious payloads. But these purpose-built quadcopters were expensive enough that they were still reserved for high-value targets. For less vital targets, they constructed long-range strike drones for deep strategic hits over 100 miles into enemy territory. Each category had its purpose, its range band, and its cost bracket. But what neither side had fielded at scale was a cheap fixed-wing kamikaze drone for the middle distance. Something that could reliably reach 20 to 30 miles behind the front and carry enough explosive to destroy a vehicle, collapse a building, or kill a logistics convoy. But that changed with the Molniya. It filled the gap in middle-range operations, something of a dead zone not only for cheap drones but for strikes in general. Artillery couldn't always reach it precisely, not if it didn't want to use the best equipment in class, which could leave it open to counterattacks from enemy artillery. But the FPVs couldn't fly that far. To fill that void, Ukraine really only had short-range tactical ballistic missiles such as the ATACMS or domestic FP2 attack drones, both of which were quite expensive to operate in numbers needed to match Russia's attacks. But the Molniya plugged that gap for between $300 and $800 per unit. In its most common Molniya 2 configuration, it carries a combat payload of 7 to 12 pounds, flies at speeds of up to 60 miles per hour, and can reach targets up to around 30 miles from its launch point. The airframe is made from plywood, plastic, and aluminum tubes. The electronics are commercial, off-the-shelf components, primarily sourced from China. One military analyst specializing in drone warfare compared it to the AK-47 of drones. It's not technically impressive, but it's still simple, reliable enough, and can be produced in enormous numbers without a sophisticated industrial base. The Molniya 2 introduced something else that hadn't been widely seen before in this class of weapon: dual-wing mounted propellers instead of a single-nose mounted one. This made it more stable when carrying a payload, improving its handling in wind and reduced the risk of catastrophic failure mid-flight. It also made it more versatile in terms of what it could carry. Confirmed Molniya payloads have included standard fragmentation warheads, thermobaric warheads from the RPO-A Schmel infantry rocket system, and the TM-62 anti-tank mine, the last of which carries the explosive equivalent of roughly 15 pounds of TNT, enough to collapse a building. The Molniya could deliver one of these to a logistics hub 25 miles from the front without a Russian soldier getting anywhere near it. That combination of middle-distance reach, meaningful payload, and sub-$1,000 costs was, for a month or so, considered to be the holy grail of drone warfare and made Ukrainian analysts wary of proclaiming they had the situation under control. As we covered earlier, what had been a relatively safe distance from the front line simply stopped being safe. And that wasn't all. Since the drone's design was made to be as cheap or as efficient as possible, you had extremely large leeway in terms of modifying it to fit certain use cases. This meant Russia wasn't fielding a single model of the Molniya, but an array of slightly different models that started with the basic build and branched from there. For example, some models had fiber optic controllers on the back, which curbed their range but made them undetectable to traditional electronic jamming mechanisms. Other models were outfitted with thermal cameras that acted sort of like a night vision and allowed better target acquisition while adding a bit of cost on advanced electronics. Still, other models eschewed the concept of kamikaze drones entirely. Rather than being equipped with a single charge of explosive to be detonated inside a target, the Molniya instead contained high-definition cameras and gyroscopic stabilizers, which allowed it to take high-quality images of the front line and transmit them back to the operator. Furthermore, the fact that the drone is essentially concocted from scraps of disparate technologies means that the manufacturing process is spread out. So long as a factory can assemble the parts, it can create new drones from imported bits and pieces. That means a single strike on a manufacturing plant only delays production until another one can get the rest of the parts. But Ukraine managed to not only copy the concept, but also improve upon it. The original Molniya had real structural problems, such as components bonded with hot glue that liquefied in summer heat. The drone's launch process still required precise multi-person coordination, where a single mistake meant the drone either failed to take off or crashed immediately. While this might sound minor, in combat conditions where a launch window might be 5 minutes wide, a drone that requires a perfectly synchronized 4-person effort to get airborne is a liability. The Blyskavka, which means lightning, addressed both issues. Structurally compromised components were replaced with 3D printed parts that could tolerate wider temperature ranges and repeated use. The launch was automated. Once the correct flight parameters are entered, the drone initiates takeoff independently, removing the human coordination failure point entirely. Ukrainian engineers also standardized the connectors throughout the airframe, meaning field maintenance and component replacement can be done faster and with less chance of error. The communication systems were upgraded, the assembly process was tightened to ensure higher consistency across units. The result was a drone that cost approximately $810 per unit and outperforms the original in reliability, range, and ease of deployment. The Blyskavka reaches speeds up to 68 miles per hour, can fly for 80 minutes, reaches altitudes of 2,000 meters, and with a signal relay drone extending its communications range, can strike targets up to 50 miles from its launch point, roughly double the effective range of the original Molniya. That relay drone as a reed transmitter concept is itself a clever solution. A small FPV positioned closer to the operational area retransmits the control signal, effectively doubling the Blyskavka's reach without requiring satellite connectivity for every mission, which would ultimately be a bit too expensive for one of the cheapest designs on the market. The Blyskavka is designed as a one-way strike platform, carrying a unified internal warhead of around 8 to 9 kilograms to deliver a direct hit on its target. By contrast, modularity in payload configuration is seen in systems like the Jetmax, which can carry 2 heavy charges or up to 8 smaller munitions for strikes against infantry, light vehicles, and unprotected infrastructure. This flexibility means a single platform type can cover a wide range of target categories, without requiring separate specialized variants for each mission profile. As of the Defense Tech Valley Summit in autumn 2025, the Blyskavka was already being supplied to the front line. Viri Drone, the company behind it, simultaneously unveiled additional platforms at the same event, including the Sokil reconnaissance UAV, intended for serial production, and the Jankoi unmanned ground vehicle, which is equipped with Starlink and capable of carrying over 1,000 pounds of payload. It means Ukraine isn't developing the Blyskavka in isolation. It's part of a widening portfolio of systems built around the same philosophy: identify the gap, fill it cheaply, field it fast. On the downside, the Blyskavka shares the fundamental limitations of its fixed-wing class. It's less maneuverable than an FPV quadcopter. It can't hover, it can't abort and reposition mid-approach in the same reactive way a multirotor can. High winds have a detrimental effect, and fog can ground it entirely. One operator, when interviewed, said he explicitly waits out a thick fog bank before proceeding with a mission. Against a moving vehicle or a target that shifts position between launch and arrival, a fixed-wing drone doesn't have the same maneuverability compared to an FPV, which can chase and adjust course at a moment's notice since it can move in any direction without facing it. But here's where money comes in. The Nemesis heavy drone, which can hover, reposition, abort mid-strike, and return to base for rearming, costs on the order of tens of thousands of dollars per aircraft and requires a ground crew, a secure launch site, Starlink hardware, and 2 trained operators per shift. The Blyskavka cost a fraction of that, and a crew of 4 can prep it in 10 minutes and launch it from a field with a pneumatic catapult. The Blyskavka isn't trying to do what the Nemesis does, it's trying to do what artillery does, meaning reach out to medium distances and hit things, but cheaper than a shell and more precise than a salvo. In that role, the fixed-wing limitations are acceptable trade-offs. Now, if you want to learn more about Ukraine's drone developments, make sure to subscribe to the channel. We post daily videos showcasing the most recent events in both Ukraine and global geopolitics. Now, while Ukraine managed to emulate the success of the Molniya in terms of offensive power, these drones ultimately have no real way of targeting one another. Their primary purpose is to serve as surface-to-surface bombardment, not mid-air dogfights on a smaller scale. Ukraine still had to somehow protect itself against the Russian drones. The answer here is a layered system, and that layering itself is significant. It turns out you need a combination of measures to counter the Molniya, including route reconnaissance, fire teams, electronic warfare, engineering protection in key areas, and stricter safety procedures during movement. What that looks like in practice is an astounding accomplishment of military tactics, technological advancement, and engineering born out of necessity. Electronic warfare jamming systems are the first line, aiming to disrupt radio-controlled Molniyas before they reach their targets. The second kinetic layer is small anti-drone fire teams, equipped with guns and modified air defense equipment. The third are physical barriers. For example, on the Izium-Sloviansk road, a 25-mile net tunnel has been built to protect logistical routes against Russian drones. The net has been designed and hung specifically to intercept low-flying fixed-wing drones on key supply routes. Anti-drone nets on vehicles, around command posts, and above troop movement corridors have become standard. Lastly, Ukraine has also made dedicated interceptor drones, which are small quadcopters that either deploy small explosives or have modified shrapnel weapons or blunt force equipment to knock enemy drones out of the sky. To illustrate the point, Ukraine produced 100,000 interceptor drones in 2025 alone, with a combat mission success rate exceeding 60%, at a cost on average 25 times less than using a Western air defense missile to achieve the same intercept. What we're looking at is the ever-evolving anti-drone ecosystem. Ukraine has built something that militaries multiple times its size haven't managed. A comprehensive, layered counter-drone architecture that operates across multiple domains simultaneously, is constantly being updated based on field feedback, and is cheap enough to sustain its scale. The Molniya and other Russian drone advancements essentially force Ukraine to build this, and in doing so, Russia may have handed Ukraine a defensive framework that will outlast this war. Meanwhile, Ukraine is simultaneously pushing its own offensive drone capabilities well beyond anything Russia has fielded in comparable price brackets. The Nemesis Regiment Starlink-equipped heavy bombers operate from hundreds of kilometers away. Ukraine's mid-range strike drones can carry warheads that weigh over 200 pounds and have been used to strike Russian radar stations, air defense systems, and aircraft. These aren't battlefield close support weapons. They're precision deep strike assets operated by crews who are nowhere near the target. The strategic implication of using drones this way is something that hasn't really been seen in modern warfare. Russia's core advantage so far has been its willingness to spend human lives, using meat-wave assaults and mass infantry operations while accepting catastrophic casualties to inch forward. A drone war, where the person pulling the trigger is tens or even hundreds of miles away from the front, removes that tool from Russia's hands almost completely. You can't threaten an operator who's sitting in an office. You can't bleed a unit dry through artillery when the operators are behind a Starlink link and a screen. Ukraine is systematically building a military where the most dangerous work is increasingly done by machines, operated by humans who are out of reach. And Ukrainian army officials claim to have made military history in late 2025 by deploying a single land drone armed with a mounted machine gun to hold a frontline position for almost 6 weeks. As Mykola Zinkovich of Ukraine's 3rd Army Corps put it, only the UGV system, short for unmanned ground vehicle, was present at the position. This was the core concept. He then summed up the strategy in 4 words: robots do not bleed. So, how did Ukraine get here? Well, the Blyskavka is not the first time Ukraine has watched Russia introduce a new drone capability, studied it, reverse engineered it, and fielded a Ukrainian version within months. The same thing happened with fiber optic FPV drones. They were first fielded by Russia in the spring of 2024. More specifically, on March 7, 2024, Ukrainian outlets shared images of a captured Russian fiber optic FPV, which uses a thin spool of fiber optic cable instead of radio signals, making it completely immune to electronic jamming. By March 18, Molniya, a Ukrainian drone development group, had showcased its own fiber optic drone prototype. It only took 11 days to go from captured enemy hardware to working Ukrainian prototypes. In the cat-and-mouse technological game of the full-scale war, it's often Ukraine that's held the reputation of being better innovators, with more motivated engineers and volunteers allowed to work in a more flexible environment. Often, if a new Ukrainian product or solution proves effective on the battlefield, like the early use of the basic FPV drone, Russia tends to copy it and ramp up production or purchasing. With fiber optics, Russia was first. Ukraine responded within 2 weeks with a prototype and was fielding operational versions within months. By late 2024, as Chinese factories ramped up production fueled by large Russian orders, fiber optic spool costs fell dramatically, from up to $2,500 per spool in 2023 to around $500 for a 10-kilometer spool by 2025, with complete fiber drones costing around $1,000 to $1,500. Both sides could reap the lower costs because Russia purchased fiber optics directly, while Ukraine leveraged the fact that Western countries already had it in supply or could purchase it from China. This ultimately contributed to Russia's effective use of fiber optic drones, which are immune to electronic warfare jamming due to their wide connection, allowing them to reliably strike targets and disrupt Ukrainian operations. The same cycle repeated with the Molniya. Russia fields it, Ukraine captures examples, Ukrainian engineers disassemble them, identify the flaws, and build a better version. The Blyskavka is in frontline service. This cycle keeps working for Ukraine for a specific structural reason. Russia's military development, even its volunteer and grassroots innovation efforts, operates inside a centralized command structure that requires approval chains, procurement processes, and institutional sign-off. Ukraine's system operates primarily through a combination of decentralized volunteer engineering networks and a centralized intelligence system that feeds information from the front line and dispenses it to manufacturers and designers. At that scale, Ukraine's military systems development can move from prototype to codification to frontline deployment in a fraction of the time. When a Ukrainian frontline platoon engineer builds a dual fiber optic and radio hybrid drone that costs a sliver more than a standard model and solves a persistent failure problem, a manufacturer can quickly formalize the design and produce a test batch. The testing system then distributes prototypes across the front line, tracking its progress in terms of real-life performance before deciding on formal development or subsequent changes. That pattern of development is leaps ahead of traditional Russian and even Western procurement and testing metrics. And it's because Ukraine simply doesn't have time to wait. Ukraine doesn't have Russia's population. It doesn't have Russia's industrial scale. It doesn't have Russia's artillery shell production rate or its tank reserves. But it has an engineering culture that responds to battlefield problems in days rather than months, a procurement system flexible enough to codify a platoon engineer's field modification within weeks, and an approach to drone warfare that's been refined across 4 years of the most intensive unmanned systems combat in military history. Most importantly, however, Ukraine knows full well that it's on a time crunch. If Russia decides to push the nuclear button, Ukraine doesn't have a response against it, and there's only so much you can achieve by pushing drones to the front line when you have roughly half of the active military size. But so long as that cycle of Ukraine's counter-development holds, Ukraine doesn't just keep pace with Russian drone innovation, it maintains an edge, because improving on a proven design is always faster than inventing one from scratch. And right now, Ukraine has gotten very good at picking up what Russia drops and handing it back harder. Russia built a cheap hammer. Ukraine picked it up, sharpened it, and started swinging it back. And if you want to learn how Ukraine is answering with more devastating weapons, check out this video. And to stay updated with the newest developments in global geopolitics and warfare, make sure to hit the subscribe button and the notification bell.